Hello, welcome back to the channel and welcome back to the video series where we are reviewing the Site Planning and Design Handbook. This video is about Chapter 2, and that is Sustainability and the Green Site. So we know that the site exists as part of a larger landscape and ecosystem, and sustainable site design must include broad consideration of the environmental role of the site as well as the program or intention of the project. Sustainable design must recognize and retain as many of the functional elements of a site as possible, but also consider the relationship between the site under consideration and the community at large. When there are changes, they bring many challenges. As we begin to think about sustainability and land development, it's important to note the contribution land development and construction make to our economic well-being. Nationwide, about 5.5% of the workforce is directly employed by the construction industry, and that is approximately 7.7 million jobs. And this is the data for back in 2005. So it's a little outdated. I'm recording this video in 2024, so please refer to some more up-to-date information. Residential and commercial construction typically represents about 10% of the gross domestic product in the US. And after mortgage debt is removed, the net value of developed real estate in the US is about $11 trillion. Construction and development represent important economic activities. With the growth in population, we can expect demand for more development, more homes, and more commercial space. So the issue is not whether we will have development, but rather what that development will be. What construction methods will we employ? What materials will we use? How will the form of our design reflect the more thoughtful and less harmful function of our projects? So let's try to take a look at all these aspects. And we're moving to the next subsection of Chapter 2, and that is Sustainable Development Principles. So we need to understand that the Sustainable Sites Initiative, a partnership led by the American Society of Landscape Architects, the U.S. Botanical Garden, and the Lady Bird Johnson Wildflower Center, is collaborating to create voluntary national guidelines and performance benchmarks for sustainable land design, construction, and maintenance practices. The initiative is a dynamic undertaking with the objective of producing a series of reports to serve the practitioner and the concerned public. Among the first of its product is the Guidelines and Principles of Sustainable Design, produced in draft form in '08. This report provides an excellent overview and specific assessments of what would be considered first principles for site designers. The definition of sustainable development is too numerous to count, and the phrase is in danger of becoming another meaningful mantra. The design professionals need to recognize the intellectual and professional challenge of finding a workable balance with nature. Sustainable design planning must include considerations of the impact of development on the local systems. The longer the useful life of a building or a site, the longer the environment has to amortize the impacts. But designing a site with an extended lifespan requires the designer to consider future uses and changes and to incorporate that thinking into the design. So what we need to remember, and there is like a little chart here, please review the guiding principles of a sustainable design. Those are basic principles that consist of doing no harm. We need to have the precautionary principles. We need to design with nature and culture, use a decision-making hierarchy of preservation, conservation, and regeneration, provide regenerative systems as intergenerational equity, support a living process, use a systems thinking approach, use a collaborative and ethical approach, maintain integrity in leadership and research, and foster environmental stewardship. So please refer back to the textbook and always back up my videos with the textbook because there are a lot of graphics and images that I would like you to be aware of. Reducing the impact of development may be possible by reducing the footprint of a building, either by modifying the footprint of the to the most efficient shape or by building multiple stories. Reducing the surface area of a structure will reduce energy requirements as well. Sites should be designed to treat stormwater as a resource, capturing runoff and encouraging infiltration, and should use water efficiently. Use native plants suited to the local climate and precipitation, and practice dryscaping techniques where applicable. Site planning should incorporate the existing environmental function of a site to the extent possible. Wetlands and important ecosystem elements such as habitat, tree masses, and stream corridors should be preserved. Green development encompasses a range of design, construction, and operational approaches that reduce the environmental impacts of development and promote human health, well-being, and productivity. Variously called sustainable design, green architecture, restorative design, or eco-design, these approaches share the following elements. The all use of regionally available, sustainably harvested, low impact, and reused or recycled materials. Design sensitivity to energy use, the incorporation of energy conservation and renewable energy generation. Also, what else is important to remember is the water conservation, water minimization, incorporation of natural light, appropriate ventilation, and human scales. Design and construction techniques that evaluate and minimize environmental impacts. Site development practices that minimize and mitigate impacts. So, energy efficiency is a central concern of green development, and 50% of US electricity is generated by burning coal, the least efficient and dirtiest of the major fuel sources. Energy efficiency in buildings can be improved through the use of natural light, building orientation, and material selection. Green buildings are healthier and more productive spaces than traditional construction. Let's talk about how we can measure the performance. Some buildings are considered high performing because of energy efficiencies, but these buildings are generally not green in a strict sense. Green buildings exist on a continuum ranging from fairly straightforward attempts to reduce the environmental footprint of a building to very sophisticated structures. Several guidelines have emerged to to guide and measure the process of designing, building, and operating a green building. Please refer to the images here. You can see a green roof that reduces the stormwater runoff and other charts. So the National Institute of Standards and Technology developed the Building for Economic and Environmental Sustainability model with support from the EPA and HUD. This approach evaluates the life cycle costs and environmental impacts of building materials in 10 years of concern, which enables designers or builders to determine the environmental loading of a material before they specify its use. The ASTM, or American Society for Testing and Materials, has also developed an approach for evaluating the life cycle costs of building materials, and that is the standard guide for environmental life cycle assessment of building materials and products, E 1991-98. This is a broad-based approach that includes consideration of embodied energy, raw materials acquisition, and environmental impacts. The best known approach is the USGBC or US Green Building Council's LEED program or Leadership in Energy and Environmental Design. This approach is chief among the reasons LEED certified buildings have been shown to have significantly lower operating costs and healthier and more productive um, occupants, in addition to protecting the environment. The USGBC created and oversees the LEED program, and there have been a few iterations of the certification. So now they're discussing LEED V5, and before that was LEED V4 and V4.1. So LEED certified professionals are employed in the planning, design, and construction processes. Projects are evaluated in these areas of concern, that's site design and planning, energy use, water management, material resources and waste, and indoor environmental quality. You can go to the usgbc.org to actually check all the requirements and to see the scorecard. A detailed review of the rating system can be found there, but we can briefly talk about that here. And LEED certified building generally will utilize the following considerations. Consideration of building position for solar axis and wind direction with regard to energy impacts. Material selection subject to environmental and life cycle considerations. Design for energy efficiency and performance. Design and select materials and equipment with consideration for high quality indoor air. Minimize waste in construction and operations. Weigh capital cost savings against operation cost savings. Use of published measurement strategies such as LEED. And sustainable site concerns include the following: landscaping for energy efficiency, rethinking ground maintenance to eliminate toxins, reducing water consumption through design, plant selection, and maintenance practices. Being aware of site-specific concerns, like soil limitations, for example. Accommodating access, possibly including public transportation. Then using site features to contribute to building performance. Locating buildings with regard to solar and seasonal influence, and maximizing local energy alternatives. So benefits to green buildings extend beyond the environmental performance of the building. Uh, Green buildings have been found to increase worker and student productivity as much as 6 to 12%. The nature of the activities in buildings is so variable that it's difficult to draw meaning from the broad claims. By looking at a narrower type of buildings, we may be able to draw some general conclusions regarding some advantages of green buildings and sites. A sufficient number of green school buildings have been constructed to provide a basis of study. Performance improves in green schools. Studies have found that indoor air quality and classroom lighting have direct effects on both teacher and student performance. The quality of air and the acoustics within the classroom have also a direct influence on student learning. When we talk about capital cost implications, we need to remember that it's more cost effective to build green ideas into a new building or site, although retrofitting offers advantages in some cases as well. Cost comparisons are difficult to assess because true or life cycle costs of traditional construction are rarely accounted for. Among the most comprehensive studies of the cost of green buildings was the 2004 Davis-Langdon study, which compared the cost of green architecture to traditional architecture from two perspectives. One, what would the cost difference be between a traditional building and the same building as a green building? And two, a direct comparison of 45 buildings seeking LEED certification and 93 buildings not seeking any green certification. So that's interesting to read. You can find that uh, publication. So, but he drew the following conclusions. Most green buildings can meet the goals of LEED within or nearly within the original program budget. Many non-LEED buildings included green elements for purposes of operational efficiency without specific regard to environmental performance or certification. And the next one is the key to the cost performance of green buildings lies in the program planning phase, the expertise of the project team, and project management or oversight. So when we talk about operating costs, the data is highly variable, but green building savings are most often associated with lower energy costs. Electricity cost savings are in the range of 45 to 55%, and some sophisticated energy conservation systems have a payback period of 7 to 9 years. So among the chief advantages to green buildings are the excellent life cycle costs. It's estimated that the life cycle savings of a typical green building is 10 times the initial investment. That is, for every 100,000 in initial capital investment, a saving of 1 million is achieved over the life of the building. So when we talk about green building materials, we know that the choice of materials is as important as the site design or choice of construction methods. Designers have significant influence over the materials used through the specs made in the design and planning, and many designers are not aware of the implications of choosing one material over another beyond cost and specific performance criteria. Materials that require less maintenance or maintenance that has a lower environmental impact are preferred. The best choice for materials may be recycled materials, although not every jurisdiction approves that. So please make sure you liaise with the local authority having jurisdiction when you select the materials for the project. Choosing a green building material involves consideration for the entire life cycle of the material, the manufacture of the material, the impacts of its use, its distribution and service life, and the disposal. Every stage of the material's life involves energy use and environmental impacts. So there are 10 impacts of building materials. Let's take a look at them. That's global warming potential, acidification potential, eutrophication potential, natural resource depletion, indoor air quality impacts, excuse me, solid waste impacts, smog, ecological toxicity, human toxicity, and ozone depletion. So each of the calculations involves converting impacts to a known and given reference a point provided in the documentation. ASTM Standard Guide for Environmental Life Cycle Assessment of Building Materials and Products describes a 4-step process for conducting a life cycle assessment: definition of goals, analysis of inventory, impact assessment, and interpretation of findings. The LCA, or Life Cycle Assessment, is comprehensive and includes considerations of embodied energy, raw material acquisition, environmental impacts from cradle to grave, and performance. Other more approachable methods have also emerged through public and private green building initiatives throughout the world. And if you are interested, you can take a look at many other regions and see their standard green building systems. So the American Society for Testing and Materials Subcommittee on Sustainability has developed a standard practice for data collection for sustainability assessment of building products. This standard includes a checklist to guide the process of evaluating the environmental character of products. Most of the processed and manufactured materials specified in site work are related to paving, utility, or stormwater pipes. Even with these few categories of materials, a wide range of choices is available for designers to consider. So let's talk about the pipe materials. They are selected primarily for stormwater drainage, sanitary sewage conveyance, or the distribution of water. Water systems commonly require ductile iron or steel pipe, but there are many choices of material for stormwater and sewage collection. Selecting pipe materials might be a matter of complying with local ordinance or preference, but selecting materials should also involve an understanding of the costs and benefits of possible choices. ABS, or acrylonitrile butadiene styrene, is used primarily as waste and storm water pipe. ABS is lighter than PVC, but is more than twice as expensive. ABS has almost twice the thermal expansion of PVC, but the resin material from which it is made is expensive to manufacture. ABS manufacture involves a number of toxic materials and environmental impacts, and instances of quality material in the marketplace have resulted in failures in the field. The next one is cast iron, and many building codes still require cast iron pipes, but these tend to be more a reflection of political and economic pressures than the value of the material itself. Cast iron is durable and has a low thermal expansion coefficient, but its great weight and associated labor costs when seem to offset those values. Cast iron is no more durable than PVC, for example, and the energy and environmental impacts of cast iron pipe manufacture are quite high. Concrete pipes, although they're very durable and resistant to wear, they are heavy and expensive to install. It is still required in some local and state codes because of the durability. The strength of concrete makes it useful in applications in which there is minimal cover or where specific loads are expected. HDPE, or high density polyethylene, is the lowest cost, lightest, and most flexible of the pipe materials. HDPE is relatively simple to manufacture, and it's the most easily recycled pipe material. It is manufactured in long sections, familiar as the coils of pipe material often used to reline old pipelines and sewers. For all of its positive characteristics, HDPE suffers from the greatest expansion coefficient of any of the popular pipe material, more than twice the thermal expansion of PVC, which limits its usefulness for many applications. And let's take a look at the PVC, or polyvinyl chloride, that is widely used because of its high strength, lightweight, low cost, easy to work with, and durability. It is used in many products, but for site concerns is used primarily as pipe or site furniture. About 60% of the PVC in the US is used in the construction industry. Available pipe diameters in PVC range from 1/8 of an inch to 36 inches. Nearly all wastewater sewers constructed in the US today are built of PVC pipe. Manufacturing PVC has some environmental costs. Vinyl chloride is a carcinogen produced from ethylene and chlorine. PVC manufacturer produces about 4.6 million pounds of vinyl chloride emissions each year. Some concerns associated with the decomposition of PVC are associated primarily with architectural or electrical uses of plasticized PVC and do not appear to be relevant to the exterior side applications of the material. PVC is difficult to recycle. A wide range of formulations are used in different products, making it difficult to use the material in the manufacture or post-consumer goods. Incinerating PVC is problematic because it has low fuel value and it turns into hydrochloric acid as it burns, increasing the wear on incinerators. And we're moving to the vitrified clay pipe or VCP. It has been largely replaced by the use of PVC, but still has some applications. Many VCP installations have been in use well over 100 years. It is durable, resistant to chemical corrosion, and has the lowest thermal expansion coefficient of any pipe material. The weight is very the weight leads to more handling and greater labor costs for installation. As PVC has become the material of choice, the availability of VCP has dropped in some areas. Recycled plastic pipe or RPP is available as a stock item in Canada, Australia, and Europe, but usually requires a custom order in the US. So quality has improved with experience, and RPP offers an opportunity to reuse plastics that might otherwise be dumped in a landfill or burned. And the pipe is manufactured in corrugated and smooth surfaces for use as stormwater and sewer pipe. Cement and concrete. Concrete is widely used in all types of construction because of its ability to be cast in a desired form and its durability once it's cured. Cement manufacturing and concrete mixing is a large business sector involving about 210 cement plants and almost 5,000 ready-mix plants in the US. The ready-mix concrete for residential purposes is approximately 12% cement. The most common cement used is Portland cement. Environmental considerations. The raw materials of cement are common, and it takes about 3,400 pounds of raw material to produce 2,000 pounds of finished concrete. The most significant environmental impacts of cement manufacturing and concrete use are the amount of energy consumed, the energy associated emissions of carbon dioxide and other greenhouse and acid formulating pollutants, the dust that results from the manufacturing process, the pollution impact on surface waters from runoff and washout water. Manufacturing cement is an energy-intensive process involving burning fossil fuels to generate the high temperature of the rotary kiln. Some cement plants have been converted to burn hazardous waste or other solid waste to extract the energy used. The high temperature of the kiln provides fairly complete combustion with low levels of residual air pollution. According to the Portland Cement Association, a single cement kiln can consume more than 1 million tires each year. Other elements of concrete do not require the substantial energy inputs of cement manufacturing, and the use of fly ash in concrete reduces the energy load even more. So the alkaline character of cement may result in runoff or washout water with a pH as high as 12. High alkalinity is particularly harmful to aquatic life. Runoff from most concrete and ready-mix sites requires a surface water discharge permit. Washout on construction sites should be properly collected and managed on site. Let's talk about fly ash concrete. We know that fly ash is a residual byproduct of burning coal that has become a common substitute for Portland cement in concrete. Fly ash is produced in the generation of electricity and industrial processes. In the past, fly ash was used for a variety of purposes, but most commonly is landfill. Replacing Portland cement with fly ash or using the two in combination reduces the amount of Portland cement required, offsetting the environmental costs to some degree as well. The advantages of using fly ash are that the concrete becomes stronger, although it may take longer for strength to develop. Also, fly ash concrete tends to increase the time it takes for concrete to set. An advantage in the summer, allowing longer working times. This may be a disadvantage in the winter. Concrete mixes can be adjusted for weather conditions. Local ready-mix plants can provide mixtures that are seasonally adjusted to a given area. Fly ash concrete requires less water per unit of volume, which reduces shrinking and cracking. Also, fly ash concrete may not accept color dyes or acid finishes with the same result as Portland cement concrete. Environmental strategies for concrete use. We need to understand that alternative designs or products that minimize the amount of material necessary may be possible. Precast products, for example, may use less material than cast-in-place alternatives and reduces on-site waste and time. Solid waste that may be produced can be crushed and used as fill. Arrangements should be made to collect washout water and control runoff from such areas. Let's talk about recycling asphalt paving. So there are several methods for recycling the removed material. It may be done in place by crushing the milled materials and mixing them with new asphalt emulsion and new asphalt materials and repaving the surface. This is often done using a train of equipment to mill, crush, and mix and repave the road in continuous ribbon. In other cases, the material is transported off-site to a plant where remixing occurs. Treated lumber, let's talk about that. So wood is widely used in landscaping, and in most contemporary applications, treated wood is specified because it lasts up to 30 times longer than untreated lumber. It could be argued that the extended service life helps to save trees and would otherwise be harvested, and this offsets the environmental problems associated with treated wood. But some concerns with using treated wood include whether the material will come into contact with people or animals or any water body, including groundwater. Alternative materials should be considered if the treated wood is to come into direct contact with food supplies. Treated lumber should not be used where it will come into direct contact with drinking water, although federal guidelines allow for incidental uses such as for docks and bridges. Disposing of treated wood is difficult. It is, after all, treated to resist decomposition. Ideally, waste wood should be recycled, but it should not be composted. Some states prohibit burning treated wood. So using treated wood is a commitment to using toxic materials in the site, basically. And the belief that pressure treated wood will last a very long time reflects a successful marketing strategy more than a fact. And there is a report that indicates that the average life of a pressure-treated deck is only about 9 years. Repeated cycles of wetting and drying inevitably begin to warp and split the wood, and the structure slowly tears itself apart. So here, please refer back to the textbook. You can see the types of common wood preservatives, and you can see creosote, you can see CCA, ACQ, and other different chemicals that are used to treat the wood. Let's talk about deconstruction. So, with interest in sustainability has come an emerging marketplace for reusable or recycled materials and the infrastructure for finding and selling those materials. So, the industry is still at the early stages of developing the methods and practices of building deconstruction, material salvage, and management of abandoned and vacant property. This may be a natural extension of the 1990s brownfield movement that focused on finding effective uses for abandoned and environmentally unsafe properties, but it points to the potential for a marketplace for recycled materials. In many cities, such structures are routinely razed, removing valuable materials such as flooring, windows, doors, trim, and fixtures allow these items to live again in a new or remodeled building. Deconstructing buildings save useful materials for reuse in new construction and rehabilitation projects and creates more jobs and business opportunities than demolition. Confirming that materials are recycled or contain recycled materials may be a necessary element in establishing a site or building that is sustainably designed. A number of organizations provide certifications of one sort or another. For example, Scientific Certification Systems, or SCS, rose out of the need for such a system created by the US GBC's LEED program. The focus is largely on finishes and building elements as opposed to site elements. But SCS does certify wood, cement, rock, and other materials used in site work. The use of recycled materials for LEED certification may require some life cycle information or documentation of origin. SCS does certify manufactured products that contain a minimum percentage of recycled materials to qualify for LEED. However, there is no formal process for documenting or certifying building materials recovered by deconstruction for reuse. So also the Reuse People, or TRP, with their headquarters in Oakland, California, is another organization. TRP typically completes an inventory of materials prior to deconstruction. To comply with IRS regulations, they require an independent appraisal to determine the value of donated materials. For example, on donation of 5,000 or more, their system tracks materials from deconstruction to the point of sale or reuse to meet IRS requirements. Then items are labeled with a unique job and piece number as the deconstruction proceeds. Materials of many pieces, such as bricks or lumber, are gathered in lots and inventoried, and then given a unique lot number. So let's talk about we're moving to the next subsection of the chapter 2, and that is sustainable site planning. So among the first considerations for the site planner is to determine how to minimize the disturbed area necessary for the project. Key aspects of minimizing the disturbed area are the degree to which habitat and open space are preserved and created. Building location. It is a critical element of site planning. The building should be located to minimize the impact on the site while maximizing the function and quality of the design space. Selecting a location is a combination of managing the solar influences on site, balancing the earthwork, and maximizing the utility and aesthetics of the site. Locating proposed structures offers the designer the first opportunity to focus the design of the site in a sustainable direction. The building location fixes the limits and extent of disturbance. Building shape may be more important than orientation, but site designers may not have influence over the shape of the building. Square buildings are inefficient shapes for heating and cooling, although they tend to be more efficient than a long, narrow building on a north-south axis. The best combination of shape and orientation is an elongated building on the east-west axis. In northern latitudes in winter, buildings orientated on the east-west axis receive almost 3 times as much solar radiation on the south side of the building as on the east or west. This situation is reversed in the summer. The location and shape of buildings can be managed to reduce the site albedo and the heat island effect created by development. The use of vegetated roofs or green roofs can further reduce these effects. So when we talk about site maintenance considerations, we need to understand that reducing the need for additional watering and reducing the chemical inputs needed to maintain a landscape are critical concerns. The choice of plant species and materials used on the site can make important contributions to the environmental performance of the site, from trees providing cool and shade to buildings and parking lots, reducing site albedo and heat generation and retention help reduce energy demand. Reduced turf area and increased use of meadows and natural vegetation increase biodiversity on the site. Selecting plants that form natural communities and have supporting interactions will reduce the need for fertilizers and pesticides. So the last subsection of the chapter 2 is moving to sustainability. And we know that sustainability concerns go beyond the selection of materials. The layout of the site, the types of and character of ground cover, and the management of the various landscape functions are critical issues. The site planning and design professions are embracing the concerns with sustainability as we grow more aware of issues of climate change, energy, and anticipated pressures of continued population growth. Uh, when we begin to consider issues for site and community design that go beyond mitigating the impacts of site disturbance and the disruption of environmental services, and also the concern with energy conservation and efficiency grow, transit planning and local sources of energy are likely to become important to communities. Also, access to local food and other resources may become important elements to the sustainable community of the near future. And this, my friends, wraps up chapter 2. Thank you so much for watching. I will see you in chapter 3.